14 resistors network. 14 resistors network and its equivalent resistance. This is a circuit containing 14 resistors of equal resistance. If R1 equal R2 equal R3 equal ... equal R14, comma, find the equivalent resistance. Find the equivalent resistance between the 2 points A and B. Find the equivalent resistance between the 2 points A and B. Given R1 equal R2 equal R3 equal ... R14 is equal R. We assume that all the resistors have the equal resistance, same resistance, which is equal to capital R. To find the equivalent resistance between the 2 points A and B, we have to consider that there are symmetrical configuration on both sides of the branch CD. Hence, VC equal VD, that is the electric potentials at the points C and D are same. The electric potential at the point C and D are same. That means VC and VD are the potentials at the point C and D, and VC will be equal to VD. As VC equal VD, no current flows through the branch CD. As VC equal VD, that means potentials at the point C and D are same. No current flows through the branch CD containing the resistances R5 and R10. Hence, current flowing through the resistor R5, that is I5, will be equal to 0, and current flowing through the resistor R10, that means I10, will be 0. Therefore, the branch CD can be neglected, because the branch CD is ineffective. No current flows through it. That is, the branch CD can be neglected. Or ignored from the circuit. Now, in what way the branch CD can be removed, or can be ignored, or can be neglected from the network? The resistor R5 and R6. Resistor R5 and R6 will be removed from the branch, or from the point C, G and D. R5 and R10 are removed from the circuit in this way. The branch CD is removed from the network or from the circuit. The branch CD is removed as it becomes ineffective, Now we consider the circuit after removal the branch CD, or after removal the resistors R5 and R10 from the circuit. Again, there are symmetrical configurations There are symmetrical configuration on above and below the point G. With respect to the point G, the configuration above the point G and configuration below the point G are symmetrical. These two parts containing the resistors R11, R1, R2, R3, R4, R12. This part containing R11, R1, R2, R3, R4, R12, and the part the part containing the resistors R13, R6, R7, R14, R8, R9 below the point G can be separated. Below the point G can be separated from uh, each other. Can be separated from each other. So you are separating these two parts from the point G. We get this type of circuit or network. Now the two parts or two loops containing the resistors R1, R2, R3, R4 and R6, R7, R8, R9 are separated from each other from the point G, and the modified circuit diagram will be uh, shown in the figure. Modified circuit diagram will be shown in the figure. Here R1 and R2 are connected in series combination, R3 and R4 are connected in series combination. Rs is the equivalent resistance of the series combination of two resistors R1, R2. Rs prime is also the equivalent resistance of the series combination of two resistors R3, R4. Similarly, equivalent resistance of R6 and R7 is Rs double prime. Rs double prime is the equivalent resistance of the resistors R6, R7. Rs triple prime is the equivalent resistance of the resistors R8, R9. We have this type of modified circuit diagram, and in this case Rs is equal R1 plus R2, that is equal to 2R. Rs is equal to 2R. Similarly, Rs is equal to 2R, which is the equivalent resistance. Rs is the equivalent resistance of the series combination of R1 and R2. Similarly, Rs prime is equal to R3 plus R4, which is equal to 2R. Therefore, Rs prime is equal to 2R. This is the equivalent resistance of the series combination of two resistors R3, R4. And Rs double prime is equal to R6 plus R7. That is, Rs double prime is equal to R. Similarly, Rs triple prime is sum of R8 and R9. Rs triple prime is equal to R8 plus R9. That is, Rs triple prime is also equal to 2R. Now we can draw the circuit diagram after considering the equivalent resistance of the parallel combination of Rs and Rs prime, and also considering the equivalent resistance of the parallel combination of Rs double prime and Rs triple prime. Here Rp is the equivalent resistance of the parallel combination of the resistors Rs and Rs prime. Similarly, Rp prime is the equivalent resistance of the resistors Rs double prime and Rs triple prime, which are in parallel combination. Therefore, Rp is equal to Rs into Rs prime divided by Rs plus Rs prime. Rp is equal to Rs by 2, where Rs prime is equal to Rs. Therefore, Rp is equal to R, as Rs is equal to 2R, where Rs is equal to Rs prime is equal to 2R. That is the equivalent resistance of Rs and Rs prime. Similarly, Rp prime is equal to Rs double prime into Rs triple prime divided by Rs double prime plus Rs triple prime. Therefore, Rp prime will be again equal to capital R. Rp prime will be again equal to capital R. Now we get the circuit diagram as what? There will be R11, R12 and Rp, which will be connected in series combination. R13, Rp prime and R14 will be connected in series combination. We can draw the circuit diagram again. We can consider the circuit diagram again where R11, R12 and RP are connected in series combination, and R13, R14 and RP prime are also connected in series combination. Now we can draw two equivalent resistances which will be in parallel combination. Between A and B we have RS, we have uh, the equivalent resistance as RS4 and RS5. RS4 and RS5. RS4 is the equivalent resistance of R11, R12 and RP. That is, RS4 is equal to R11 plus RP plus R12. Therefore, RS4 is equal to 3R. RS4 is equal to 3R, which is the equivalent resistance of the three resistors R11, RP, and R12. RS4 is equal to 3R. Similarly, the equivalent resistance of the series combination of R13, RP prime and R14 is RS5, which is equal to R13 plus RP prime plus R14. Putting the values of the resistances, we get RS5 as equal 3R again. RS5 is equal to 3R. Therefore, the equivalent resistance between the 2 points A and B will be RS4 into RS5 divided by RS4 plus RS5. As RS4 and RS5, RS4 and RS5 as the equivalent resistances RS4 and RS5 are connected in parallel, combination between the 2 points A and B. Between the 2 points A and B, so we can say that RAB will be equal to RS4 divided by 2, and putting the value, we can write RAB as 3R into 3R divided by 3R plus 3R. Therefore, RAB is equal to 3R divided by 2. RAB will be equal to 3R divided by 2. This is the equivalent resistance. Between the 2 points A and B. Between the 2 points A and B, RAB is equal to 3R by 2. This is the equivalent resistance between the 2 points A and B. That is, RAB equal 3R divided by 2.